You all know that the method of grouping elements into different classes. See, in nature, so many elements have been discovered so far, and it's extremely difficult to study each of these elements in detail without some basics. So, in order to avoid the confusion of learning about a large number of elements, it is very much easier to group these elements into different classes to make the study more easy. So, we know that the elements are the basic units of all types of matter. See, as years ago, like in 1800, only 31 elements were known, and around 1865 the number of known elements were more than double to 63 from 31, and at present 114 elements are known, and recently discovered elements are man-made, and also efforts to make new elements are continuing. With such a large number of elements, very difficult it is to study individually the chemistry, the properties and nature of all these elements and their compounds individually. So, to overcome this problem and make the study of these elements very easy, scientists search for a systematic way to organize their knowledge by classifying the elements, and it also would rationalize the known chemical facts about elements and also predict new ones for undertaking further study. Now, first of all, we will see what is Daubeney's triad. So, in 1817, a scientist called Daubeney, what did he discover? He found out that elements could be arranged in group of 3 known as triads. So, what was the way in which he arranged such elements? So, he took 3 elements in such a way that the middle element's atomic weight was the average of the other 2 elements. See, for instance, sodium, its atomic weight is 23, and the other 2 elements on either side of sodium is lithium and potassium. See, add up these two, 39 plus 7, 46. So, the average of 46 is 23. So, like that he grouped 3 elements together, and that is what we call Daubeney's triad. Now, another scientist called Newland, he came up with another law of classification or grouping of elements known as law of octaves. You know that octaves are like in music we have got notes from sa, sarigama, padanisa, like that. So, Newland in 1865, what did he discover? He arranged the elements according to the increasing order of atomic weights in such a way that the properties of every 8th element were identical to the first element, and Newland called that the law of octave. So, it is very easy to understand the law of octave. But what was the problem with this particular law? It was that the law of octave seemed to be applicable or true only for elements up to calcium, and his idea was not very widely accepted at his time, but later he was awarded Davy Medal in 1887 by Royal Society of London. Now, next you can see here the Newland's octaves 1, 2, 3, 4, 5, 6, 7 and 8th element sodium. See, it is placed under lithium. So, every 8th element is similar to the properties of the first element of the group. Now, next, Dmitri Mendeleev. So, he was a very famous scientist, and the periodic law as we know today owes its complete development to the Russian chemist Dmitri Mendeleev from 1834 to 1907, and there was another scientist along with him, German chemist. His name was Lothar Meyer from 1830 to 1895. So, they both worked independently, and in 1869 they proposed that when elements were arranged according to the increasing order of the atomic weights, there were similarities in physical and chemical properties at regular intervals. So, properties of elements are periodic functions of their atomic weight was the law suggested by Mendeleev. Now, Mendeleev's periodic table is based mainly on the atomic weight, and as already said, his law states that properties of elements are periodic functions of their atomic weight, and his table had 7 horizontal and 8 vertical columns, and in his table 0 groups were not included, and he arranged 65 elements in the table, and it was clear that there were so many gaps of missing elements present in the table, and Mendeleev made several predictions about the properties of these missing elements. And what did he predict? 4 elements like Eka boron Eb, Eka aluminium, Eka manganese and Eka silicon would be discovered in future. Now, what was Mendeleev's prediction mainly? So, Mendeleev arranged elements, as I already said, in horizontal rows and vertical columns in the order of increasing atomic weights. So, the similar properties elements were occupying the same vertical column or group. But he realized that many elements did not fit in this scheme of classification in the order of atomic weight if it was strictly followed. So, what he did, he ignored the order of atomic weights, thinking that atomic measurements might be incorrected. So, he placed the elements with similar properties together. So, if you take an example like iodine with lower atomic weight than that of tellurium belonging to group 6 was placed in group 7 along with fluorine, chlorine, bromine because of the similarities in their properties. And he proposed that some of the elements were still undiscovered, and so he left several gaps. So, we already learned that he left the gap under aluminium, gap under silicon, and called these elements Eka aluminium, Eka silicon and all that. And actually these elements were discovered at a later stage. And what were the defects of Mendeleev's periodic table? As we have already learned before, the position of the first element hydrogen, it was not correctly defined. Then certain pair of elements, the increasing order of atomic masses, it was not properly obeyed. Then there is no separate places of isotopes in the periodic table, and some elements were dissimilar and they were separated, and similar elements were separated, dissimilar elements were grouped together, contradictory factor. And he could not explain the causes of periodicity as well among these elements, though he grouped the similar elements in a separate way and dissimilar elements together. He could not predict the periodicity in properties. Now, what does the modern periodic law say? That is, in 1942, Moseley gave this law which was based on atomic number. So, what does this law state? It is very important. That is, the physical and chemical properties of the elements are periodic functions of atomic numbers. So, before it was classified on the basis of atomic weight. So, there were so many defects, and for many properties the correct explanation could not be given based on that factor. But after that, the properties of elements were said to be the periodic function of their atomic numbers instead of atomic weights. That is a modern periodic law. So, modern periodic table, that is also known as a long form periodic table or Bohr's table. So, here in this table there are horizontal rows called periods and vertical columns called groups. So, row means period means from left to right, top to bottom means group. So, 7 periods, and each period start with a different principal quantum number, and 18 groups are there in the long form periodic table, and separated from the table down there are 2 series at the bottom, and they consist of 14 elements after lanthanum and 14 elements which followed actinium, and they are known as lanthanides and actinides respectively. So, hope you understood clearly the modern periodic law, which is based on the atomic numbers. Then how Mendeleev the previous classification of elements by Daubeney, triad law of octaves by Newlands and all that. So, keep all these laws in your mind. Now, here we have already learned the number of elements in each period. Period n orbital energy field, then number of elements, first oneness, then the number of elements would be 2, here in second period 2s 2p, number of elements 8. So, like that it goes on, you just go through all these, and in the 7th period the number of elements are incomplete. Now, what were the achievements of the Mendeleev's periodic table? So, some cases elements slightly having higher atomic masses were kept before the elements having slightly lower atomic masses. So, the sequence could be inverted so that the elements with similar properties were grouped together, like cobalt 58.9 came before nickel 58.7, though the mass is slightly different. So, Mendeleev also left some gaps for elements which were yet to be discovered at that time. Now, what were let us continue with the achievements of Mendeleev's periodic table. And Mendeleev named them by prefixing a Sanskrit numeral Eka. Eka in Sanskrit means 1 to the name of the preceding element in the same group, like scandium, gallium, germanium and all that, which were discovered later. They had properties which were similar to Eka boron, Eka aluminium, Eka silicon. See, Mendeleev had that much of insight, future insight in his mind, that in future if these elements were discovered, where they could be placed. So he had exactly left those gaps in his periodic table. And noble gases like helium, neon, argon, they were all discovered very late because they are very inert, and in the atmosphere they are present in very low concentrations or measures. So when these were discovered, they could be placed in a new group without already disturbing the already present groups. Now, what were the limitations of Mendeleev's classification? So the main defect was that he could not say a correct position to hydrogen. So he placed hydrogen with alkali metals and also with halogens. Because alkali metals, like them, hydrogen combines with halogens, oxygen and sulfur to form compounds. And also like halogens, hydrogen exists as diatomic molecule like H2. And it can combine with metals and non-metals to form covalent compounds. So what are isotopes? Isotopes of an element, they are having similar chemical properties, but their atomic masses are different. So according to the increasing order of atomic masses, they should be placed in a different group, but since they show similar properties, they should be placed in the same group. So the position of the isotopes could not be ascertained properly. So that was another, because hydrogen and all, it has got 3 isotopes. So where to keep them properly, it was a total confusion in Mendeleev's classification. Then there was a wrong order of atomic masses for very few elements. Even though Mendeleev arranged the elements in the order of increasing atomic masses, very few places in his table the order wasn't followed correctly. Like aluminum 29.98, it was placed before silicon 28.09. Actually, more mass of aluminum means it should come after silicon, but it was placed before silicon in his table. Then irregular increase in atomic masses. So here the atomic masses did not increase in regular manner when you go from one element to the next. So it was very difficult to predict how many elements were discovered between these two elements because of that. And in 1913, Henry Moseley, in his modern periodic table, he showed that atomic number was a more fundamental property than atomic mass. And Mendeleev's periodic table was modified and atomic number system was adopted as the basics. And the modern periodic law, it says that properties of elements are periodic function of their atomic numbers. So here the prediction of elements properties could be made with more precision, and when they were arranged in the increasing order of the atomic number. So here the modern periodic law helps us to overcome the 3 limitations of Mendeleev's periodic table. So I hope you understood well the concepts of the merits and demerits of Mendeleev's periodic table and the concepts of the modern periodic table. Now, position of the elements. When we talk about the position of elements in the modern periodic table, it had 18 vertical columns which were known as groups and 7 horizontal rows, that is from left to right, known as periods. So the arrangement of elements were based on their electronic configuration, and there is an irregularity when you go to the position of hydrogen, because it cannot be placed either with group 1 metals, because the electronic configuration of hydrogen is very similar to alkali, but nor it can be placed in group 7 with halogens because it forms diatomic molecules. And the atoms of different elements with the same number, they occupied shells that are placed in the same period. Also, the position of an element in the periodic table, what does it say? It tells us about the reactivity of the particular element, and also the valence electron, because the number of electrons in the outermost shell, known as the valence electron, helps to determine the properties of and the kind and the number of bonds formed by any element. Next, you can see chart of the modern periodic table with the position of the hydrogen given in green, and you can see the right end marked in red are noble gases. Then here we are having transition elements, and bottom you can see lanthanides, actinides and all that. You can see alkali metals. Then all these according to the colors you can identify. For your easy reference, I've included the colored table, so you can find out the positions of elements more easily. Now, what are the trends in the modern periodic table? What do you mean by trends? Valency, atomic size, various factors like that. So valency, how do you find out the valency? It depends on the number of electrons in the outermost shell present in an atom. So how does it vary along a period? That is, from left to right, when you go through each period, the valency will increase from 1 to 4 and then it decreases to 0. And when you go down a group, the number of valence electrons in any group, it is the same. So all elements in any group, if you take it, will have the same valency. The atomic size, what is atomic size? Actually it is the radius of an atom, how big it is. How does it vary in a period? When you move from left to right, the size of the atom will decrease, because when you move from left to right, the new electrons occupy the same existing shells. So because of that, the attraction of the nucleus towards the outermost orbit will be very strong. So the nucleus will hold the electrons tightly towards itself. So the atomic size will not increase. But what happens when you go down a group? New electrons which are added will go to new shells. So the outermost shell will be very much far away from the nucleus, and the size of the atom will increase. Okay, now with that we come to the end of the first part of this particular section, and I have actually divided this lesson into 3 parts, and I will be uploading 2 more sessions of this lesson along with the MCQs and most important topics, as well as any tricks or mind maps. And after finishing all the topics, I am planning to work out the exercise questions after the lesson and upload it for you. So I advise you all to revise these lessons very quickly and frequently, so that you can avoid the last minute rush of revisions just before the exam, and no need to panic or be worried whether you can finish it off at a given time, because if you start revising it from earlier stages, towards the last week of the exam, you just need to brush up through all these lessons. So I will be coming up soon with the next session, and hope you like this video. Please do like, share and subscribe to my channel, and share it with your friends, and do not forget to press the bell icon, because you will get notifications as soon as I upload new videos. And with that, I am winding up today's session, and thanks for watching my video. Welcome all back to my channel, Chemistry Made Simple for NEET. I am Dr. Radha Subramaniam with a PhD in chemistry. So today we are going to continue with classification of elements and periodicity in properties of class 11. So out of the 3 parts, I have already uploaded the first part. I hope all of you have watched it, and those who have not viewed it can go back to the video, and once watching it and getting clear about all the concepts, you can continue with the second part. So we were talking in the last session about some of the important tips for the NEET aspirants. So another important thing you should remember is that you have to know your capability. Your hard work from the beginning of this year has probably shaped you into a knowledgeable and skillful person, and by now you might have as well known your strength and weakness. But at this point of time, it is important you have to stick to your strengths and know what you are capable of doing during the exam time. And most important thing is to stay motivated. Having a positive mindset is very important, as it gives you the ability to be productive. Taking breaks during your last minute preparations sharpens your mind. Therefore, take your time to spend some time doing what you love. Talk to your parents or friends. It will refresh your mind and also help you stay motivated. Remember, getting an 8 hours of sleep is a must. It gives you the energy and motivation you need. So with that, I will be continuing with the second part of classification of elements. So first we will see about the metallic and non-metallic properties. We were talking about the periodic properties, modern periodic law, and different laws proposed by different scientists. Like we studied about Dobania's triads and law of octaves by Newland, and then modern periodic table, which is based on atomic numbers rather than atomic weights, and We were discussing about Mendeleev's periodic table in our last session. So in the modern periodic table, you can see one zigzag line here given in red. So this line separates metals from non-metals. So metalloids are the borderline elements. See, these are the borderline elements. What are they? Boron, silicon, astatine, then tellurium, then Sb, that is antimony, polonium. These are all the elements which show properties of both metals and non-metals. So they are intermediate between metals and non-metals. So we call them metalloids. Now, where do you find metals in the periodic table? So we can find them on the left side of the periodic table. And variation in a period, like when you move from left to right of a periodic table, the metallic character of element will decrease and they tend to become more non-metallic in nature. And going down a group, the metallic character of elements increases. What do you mean by metallic character? What are metals actually? So they are capable of just donating their electrons, because it is very easy to remove electrons from the valence shell of metals. So metals donate ions and form positive ions. So that is what we call as metallic character. Non-metals, on the other hand, they have a tendency to accept electrons and become negative ions. And now non-metals are found on the right hand side of the periodic table. So from moving from left to right, non-metallic character will increase, and moving down, non-metallic character will decrease. Now metal oxides are basic in nature and non-metallic oxides are acidic in nature. Just remember that, which is useful for MCQs. Then on moving from left to right, basic nature of oxides will decrease and acidic nature of oxide. Basic nature, what will happen? Acidic nature will decrease. Now variation in a group is on moving down the group, the basic nature, it is opposite. Basic nature of the oxides will increase and acidic nature of the oxide will decrease. So here it is just the opposite. On moving from left to right, the basic nature of the oxides will decreases and acidic nature of the oxides will increase. Here it is vice versa, opposite. Moving down, basic nature will increase and acidic nature will decrease. Now you can see that when you go from left to right, metallic properties will decrease, and moving up the group also the metallic property will, here it will increase, moving up the group. Now metallic character, what is it used to define? The chemical properties that metallic elements present. So generally metals properties are to lose electrons and to form cations. What are cations? Positively charged ions are called cations, and non-metals gain electron and form negatively charged ions, they are called anions. So they have a high oxidation potential, and so they are easily oxidized and strong reducing agents, and they form mostly basic oxides, and more basic the oxide, the higher the metallic character. So when the basicity of the oxide increases, the metallic character also will increase. Now electronegativity increases when you move from left to right, and when you move up the group also electronegativity will increase. Now how can you define electronegativity? What is actually electronegativity? It is a measurement of an atom to compete for electrons in a bond. So the higher electronegativity, the greater will be the ability to gain electrons in a bond. So you can relate electronegativity with ionization energy and electron affinity. So whenever electrons having low ionization energy, they have low electronegativities. Why? Because they are nuclei, they do not exert strong attractive force on the electrons. Elements with high ionization energy, they have high electronegativities because of the strong pull exerted by the nucleus, which is positively charged on the negatively charged electrons. So when you move from bottom to top, electronegativity increases, and also it increases from left to right. So remember that is very important. Electronegativity increases from bottom to top when you go up, or from left to right. Now next is electron affinity will decrease or becomes negative when you move from left to right, or when you move up the group. So what is electron affinity? That is the energy change happening when you add an electron to a neutral gaseous atom. So you can further give an explanation for electron affinity, like it is the enthalpy change resulting from adding an electron to a gaseous atom. When you add an electron to a gaseous atom, the enthalpy change occurring is also known as electronegativity. So it can be either positive or negative. So the greater the negative value, the anion will be more stable. Now ionization energy increases when you move from left to right of the period or moving up the group. What is ionization energy? That is the removing of an electron from an atom. It requires energy to overcome the pull of the positively charged nucleus. So ionization energy is the energy required to completely remove an electron from a gaseous atom or ion. So always that is positive. Remember, always ionization energy is positive. So the energy required to remove one valence electron is known as the first ionization energy. Second ionization energy is the energy required to remove second valence electron, and it keeps on going. So first ionization energy, just look here, sodium. So Na plus 1 electron. Then Na plus, from here we are removing another electron, you get Na2 plus another electron, like that. Now when you go across a period, that is from left to right, atomic radius will decrease. When you go up a group, the atomic radius, that also it decrease. When you go down a group, atomic radius will increase. Don't get confused. Moving up a group, atomic radius will decrease. Why? Because in transition metals like 3D series, the change in atomic radius is smaller when you compare it with representative elements across the period. Why is why there is a change in atomic radii? Because it is still smaller among inner transition elements. That is, when you compare with 3D series, it is smaller in 4F series. Because the ionization enthalpies are intermediate between S and P block elements. Because of that, they are less electropositive than group 1 and 2 metals. So here what happens is that when you add an electron to a neutral gaseous atom to convert it into a negative ion, enthalpy change accompanying this process, we call it electron gain enthalpy. So according to the nature of the element, when you add an electron to the atom, it can be either the reaction occurring can be endothermic or exothermic. So group 17 elements like halogens, they have high negative electron gain enthalpies because they have got a stable noble gas electronic configuration by picking an electron. See, if they accept one more electron, now their octet will be satisfied. And on the other hand, noble gases have very highly positive electron gain enthalpy because of the inert gas structure, and the electron has to enter the next higher principal quantum level, leading to a very unstable electronic configuration. Now you consider the same principal quantum level. What happens is that an S electron is attracted to the nucleus more than a P electron. Remember this point always. S electron is attracted to the nucleus more than P electron. So if you take as an example element beryllium, when during ionization the electron removed is an S electron, and in case of boron the electron removed during ionization is P electron. So in beryllium it is S electron, and in boron it is a P electron. So the penetration of a 2s electron towards the nucleus or inside the nucleus, it will be much more greater than that of a 2p electron. So in boron, the 2p electron is more shielded from the nucleus by the inner core, the elements present in the electrons present in the inner core, than 2s electrons of beryllium. So it is very easy to remove 2p electron from boron than the removal of 2s electron from beryllium. So this is an important point, just remember that. So boron has smaller first ionization enthalpy than beryllium. Now the effective nuclear charge felt by valence electron in an atom is less than the actual change it is less than the actual charge on the nucleus. Why? Because of the shielding or screening effect of valence electron from the nucleus by the core electrons. So shielding is effective when the orbital is in the inner shells. When they are completely filled, the shielding will be very effective. Then across a period, increasing nuclear charge outweighs the shielding. So what happens is that the outermost electrons are held more and more tightly, and because of that the ionization enthalpy will increase across a period. So across a period, what happens? The nuclear charge will increase. So because of that, it is more effective than the shielding. So that is why the outermost electrons are held more tightly, and the ionization enthalpy also will increase across a period. And always you have to remember that the size of the anion is larger than that of the parent atom, because when you add one or more electrons, that will result in an increased repulsion among the electrons, and therefore a decrease in effective nuclear charge. Take an example. For fluoride ion F minus, the ionic radius is 136 pm. Atomic radius of fluorine is only 64. See, it is more. But if you take the atomic radius of sodium, it is 186 pm when you compare it with the ionic radius of Na, which is 95. So you can compare these two. And what is isoelectronic species? These are atoms and ions which contain the same number of electrons. And you can see the variation of atomic radius with atomic number for alkali metals and halogens. You take the atomic number Z along the x-axis and atomic radius along the y-axis. So you can see that the atomic size increases generally. You can see I've included two charts over here. Here also you can see another graph, and what happens is that normally the atomic size decreases across a period for the elements of the second period, because within the period the outer electrons are in the same valence shell, and the nuclear charge will increase along with the atomic number, resulting in the increased attraction of electrons to the nucleus. So within a family or a vertical column of the periodic table, the atomic radius will increase with the atomic number. So for alkali metals and halogens, as we described, what will happen is that the principal quantum number n, it will increase, and the valence electrons move away, or they are far from the nucleus. So this happens because inner energy levels will get filled up with electrons, and they shield the outer electrons from the attraction or pull of the nucleus. So because of that, the size of the atom increases as reflected in the atomic radii. And now what happens is that within a family, as I already said, the atomic radius will increase with the atomic number. And as I explained already, for alkali metals and halogens, when you go down, the group principal quantum number will increase, and the valence electrons are away from the nucleus. As the inner energy levels are filled with electrons, they shield the outer electrons from the pull of the nucleus. It's very simple explanation. You just need to go through it once or twice. You will understand the concept, and the size of the atom increases, therefore, which is reflected in the atomic radii. So with that, we are coming to a conclusion of the part 2 as well. This lesson, particular unit, is extremely easy because we are only going through a few periodic laws and few concepts like the atomic radii, ionic radii, and regarding the properties of elements based on the periodic table and all that. So I'll be uploading the third part as well, and after that we'll be doing a few important MCQs. So please don't forget to like, share and subscribe to my channel, and do share it with your friends, and don't forget to press the bell icon so that you will get the notification immediately as soon as I post a new video. So with that, I am winding up the session for today. Thanks for watching. Welcome back everyone to Chemistry Made Simple for NEET. I am Dr. Radha Subramaniam with a PhD in chemistry. So already I have uploaded previous sessions, different units of classification of elements, and from class 11. So today I am continuing with the next part, that is the third part of the lesson of class 11. So before we move on to today's session, I just would like to remind you all about the importance in building up of interest in subjects. And it's one important thing for good NEET preparation is your interest in subjects. Like mainly you have to build up your interest in physics, chemistry and biology. If you love solving problems, understanding concepts, you will want to focus on studies as much as possible, keeping all distractions away. Be consistent with your study time. And the most important thing is that remember your goals, write them down, use sticky notes and paste above your study table or any other place where you can see them regularly. It can be like, I want to crack NEET with a very good rank and will study in a top medical college. So, why are you doing this? Write the answer of the above question and continue to remind yourself about it. So, with that I will be continuing with the third part of the session. Now, we were talking about Mendeleev periodic table, then Ncert we had already discussed, then we also learnt about the law of octaves by Newland, and also various other concepts like electronegativity, ionization energy, atomic size, and so many things in our previous sessions. So, as we have already discussed, the atomic size decreases across a period, that is from left to right when you move across a period. Since the electrons are added to the same valence shell, and since due to the powerful attraction of nucleus towards the outermost shell, then the size of the atom will decrease. And also within the period, outer electrons in the same valence shell, because of that the effective nuclear charges increase and the atomic number will increase. So, as a result, the increased attraction of electrons to the nucleus will happen. Now, what are the trends in physical properties? There are numerous physical properties of elements, as you know well, like boiling point, melting points, then latent heat of fusion, vaporization, energy of atomization and all. They all show periodic variations, but we will discuss the periodic trends with respect to ionic and atomic radii, then ionization enthalpy, electron gain enthalpy and electronegativity. So, we discussed about all these terms in our previous sessions. For those who haven't watched those sessions, I would like all of you to go back to those sessions and have a look at it again before you continue with this session. Now, you know, for metals, what are metals? Already I explained about metals yesterday, that is they have got the outermost valence shell loosely attached to the atom, and it is very easy to remove electrons from the outermost shell, so that the atom would attain a positive ion, or it becomes a positive ion. So, here metals, we define the term metallic radius. What is it? It is taken as half the internuclear distance which separates the metal cores in the metallic crystal. Suppose the distance between two adjacent copper ions and solid copper, if it is 256 pm, then the metallic radius of copper will be around 128 pm. Now, atomic radius is used to refer to both covalent or metallic radius, depends on whether the element is a metal or a non-metal, and it can be measured by X-ray or some other spectroscopic methods. Now, you know what we call the elements of group 1, they are known as alkali metals, and group 2 are called alkaline earth metals. So, they have respectively the outermost electronic configuration NS1 and NS2, and they all are reactive metals with low ionization enthalpies. Now, you know S block elements, as I have listed here, we know the outermost electronic configuration. So, what is shown here? Lithium, beryllium, sodium, magnesium, potassium, calcium, rubidium, strontium, these are all belonging to S block. Now, the 7th period N is equal to 7. So, these are similar to the 6th period when the successive filling up of 7s, 5f, 6d, 7p orbitals takes place. Remember which all subshells are getting filled up, and includes most of the man-made radioactive elements. And this period is ending up with the atomic number 118 belonging to the noble gas family, and filling up of the 5f orbital after actinium with atomic number 89, it gives the inner 5f inner transition series, which we call as actinoid series. Then the 4f and 5f inner transition series are placed separately, as I have explained already, underneath the periodic table as a separate block to maintain the structure and to preserve the principle of classification, how we keep like similar elements having similar properties in a single column. Now, the 3rd period, it begins with sodium, and the newly added electron goes to 3s orbital, and successive filling happens at 3s 3p orbitals, and which gives rise to the 3rd period of 8 elements from sodium to argon. Then the 4th period N is equal to 4 starts with potassium, then the added electrons get filled up at 4s orbital. Now, you know that before the 4p orbital is filled, 3D orbitals filling up becomes energetically favorable. So we come across the 3D transition series, that is what we call as 3D transition series of elements, which starts from scandium atomic number 21 having electronic configuration 3d14s2. The 3D orbitals are filled at zinc 30 with electronic configuration 3d10 4s2. Fourth period ends at krypton and filling up of 4p orbitals takes place. Altogether there are 18 elements in fourth period. Now the fifth period, n is equal to 5, begins with rubidium, which is similar to the fourth period, and it has 4D transition series starting at yttrium with atomic number 39 and ending up with xenon filling up of 5p orbitals. And sixth period n is equal to 6, which has 32 elements, and successive elements enters 6s, 4f, 5d, 6p orbitals in that order. The filling up of 4f orbitals begins with cerium with atomic number 58 and ends at lutetium with 71 as atomic number to give the 4f inner transition series. We call them lanthanoid series. So you go through these particular concepts very carefully regarding actinides, lanthanides and different periods, starting with which element, ending with which element, then the filling up takes place in which orbitals. That all you have to know, because you are sure to get objective questions from these sessions. Now we know D block elements. We already had that lesson separately in 12th class. I have already uploaded that lesson in detail. You can go through it. So here is the list of D block elements, and then next is D block elements. We call them also transition elements. Outer electronic configuration would be n-1, D1 to 10 and ns 0 to 2. All of these are metals. Then zinc, cadmium and mercury has electronic configuration n-1, D10, ns2. They do not show most of the properties of transition elements. Remember this in particular. So the exceptions which do not show the properties of transition elements, those three elements, zinc, cadmium and mercury. Now p block elements. So you know p block elements, there are 6 groups of p block elements in the periodic table from 13 to 18: boron, carbon, nitrogen, oxygen, fluorine, helium. These elements set the groups, and the valence shell electronic configuration would be ns2 and in p1 to 6 except for helium, and the inner core of the electronic configuration might differ in some cases. So these together with s block elements, p together with s block elements are called the representative elements or main group elements. Remember what is known as representative elements. And general outer shell configuration is ns2, as I said already, np1 to 6, n is equal to 1 to 7, and there are 36 p block elements in the periodic table. So I have included all the most important points and I have tried to cover most of the concepts from NCERT textbook, so that the last minute revision would be extremely useful and easy for you. So this is a quick revision. As I said before, this is not a total teaching of the concept or the chapter. I am just trying to quickly make you revise all these portions which are extremely important, and I have made these notes extremely simple for you to learn at the last minute without getting panicked or tensed up. Now next, F block elements, already lanthanoids and actinoids, and you can watch the session which I have uploaded before regarding this also. And F block elements are also called inner transition elements, and general outer shell electronic configuration would be n-1 f1 to 14 and n-1 d0 to 1 ns2. all these are metals. The 14 elements of the first series from Ce Z58 and Lu Z71, these are called lanthanides, or they are also called rare earth metals. Then 14 elements of the first series from Th Z90 to Lr Z103, these are called actinides or actinoids, and elements after U are called, or uranium, are called transuranium elements. So remember what is meant by transuranium elements, and also actinides, actinoids and all that, just keep in mind, and what are inner transition elements and all these things. Now next is what are metals, non-metals and metalloids. Metals, they comprise more than 78% of the total known elements. All S block, D block and F block elements are metals. And metallic character increases down a group and it decreases along a period when you move from left to right. So remember that points again. So which I am again repeating the most important concepts so that it will be in your mind all the time, then you can have better retention of all these concepts. That is why I am repeating some of the important concepts again. And then what are non-metals? So non-metals are very few in number, that is 18. These are, I have given the names of all the elements, you can just go through that. Then the non-metallic character, we already learned, it increases when you go from left to right across the periodic table. Then the metalloids, like which lie along the borderline between metals and non-metals in the periodic table, they are called semi-metals or metalloids, and the list is given below, silicon, germanium and all that. And you just keep in mind the symbols and the names you have to write in your book and remember all the names of the elements with their symbols. Now next is what is meant by oxidation state. We can give a quick definition for oxidation state of an element in a particular compound. How can you define it? It is a charge acquired by the atom on basis of electronegative consideration from other atoms in the molecules. In molecule there would be other elements also. So there will be other atoms also. So with respect to that atom, on that basis we can define it as a charge acquired by the atom. Now next is, what are the anomalous properties of second period elements? First element of each group 1, that is lithium, and the second beryllium, and group 13 to 17 boron to fluorine, they differ in so many ways from other members of the respective group. So if you take an example, unlike other alkali metals, lithium and beryllium, unlike other alkaline earth metals, they form compounds which has more covalent character, which shows more trend towards a covalent character, whereas the other members of these group predominantly they show or they form ionic compounds, or they show ionic character. So the behavior of lithium and beryllium, it is more similar with the second element of the group belonging to magnesium and aluminum respectively, and this sort of similarity we call it as diagonal relationship in the periodic properties. Just remember this point and keep it in your mind, because I always say that better you take printout of these concepts and you keep it in a file for your easy reference just before the exam. And now with that we are coming to an conclusion of this session also, and soon I will be uploading the most important and probable questions or MCQs which are likely to come from this topic. So once I finish all the unit, again I repeat that I will be uploading more MCQs, all the ones which are very important and which have come for previous years NEET question papers, and I will be trying to solve NEET question papers for you, along with uploading the exercise questions, and I will be solving the sums for you whichever lessons they have, and then share with you the mind maps so that it will be easy. And I would like to say that when you prepare mind map, so since you are enclosing that in a single foolscap paper, it is a little bit difficult for you to read because we have to write it really small, but still I try to take close-ups of each section so that you can take a screenshot of that and keep it for your reference. And with that I am coming to a conclusion of this session, and please do like, share and subscribe to my channel, and share the sessions and videos with your friends, and also don't forget to press the bell icon so that as soon as I post new videos you will get the new notifications immediately. Thanks for watching the video. Welcome back to my channel Chemistry Made Simple for NEET. I am Dr. Mahalakshmi Subramaniam with a PhD in chemistry. Today I am going to show you all a very easy and excellent trick to write the electronic configuration of any element. Come on, without wasting our time, shall we start our session? Before that, please don't forget to like, subscribe and share my channel. Okay, now you can see here, like I have written electronic configuration, and as you all know, we have got 4 subshells or 4 orbitals called s, P, D and F. I am sure that you all know these 4 subshells. So S subshell can accommodate a maximum of 2 electrons. P subshell can have maximum 6 electrons. D has maximum of 10 electrons and F has maximum of 14 electrons. So you can see always how do we write a pair of electrons inside a box. I have seen many students writing either like 2 arrows pointing in the same direction. This is a wrong way to write. Or 2 arrows pointing in the downward direction. That is also wrong. 1 arrow should be pointing upwards and 1 arrow should point downwards. That is the correct way to write the electron pair inside each box. Now this shows 2 electrons. Suppose we are writing or filling up this table or this box. How do we fill it up? So for that, if you have 3 electrons in total, so always what you have to do is first fill the first box with the first electron, then the second one goes to the next box, then the third one goes to the third box. So I have seen many students who are very much confused in how to fill up the electrons inside the boxes. So after that, suppose you are having a 4th electron, then that electron will come here. So then if you have got a 5th electron, then it will go to the next box until the whole box is filled. Here also for d orbital, suppose we are having 5 electron, means 1, 2, 3, 4, 5. This is how it is filled up. 6th will go here. 7th will come here. So like that it goes on for even f orbital. So before in the textbook and in previous classes you would have learned how to write the electronic configuration. So what you would do is first you write from 1s to like 1s, 2s, 3s, 4s, 5s. It goes down like this. Then near to 2s you start with 2p, 3p, 4p, 5p, 6p. Then after 3p in the same row you write 3d, 4d, 5d. Then starts 4f, 5f, like that. So after that you see you put diagonals like this. See, this is the direction of the diagonals. And then from here, how do we take the subshells? How do we write it? First you write 1s, then 2s, then 2p, then comes 3s, then after that 3p, 4s. See, 3p, 4s, then you have to write 3d, 4p, 5s. Okay, 3d, 4p, 5s, then 4d, 5p, 6s. 4d, 5p, 6s, then after that 4f, 5d, 6p, 7f. That is 4f, 5d, 6p, 7s. So, you know, for your examination, it is very difficult to write the whole subshells like this, then putting arrows and all that. It takes a lot of time. Then you have to write it in this method. Only then you can fill up the electronic configuration. So, to overcome all these hurdles, I have provided a very simple trick which is very easy for you to understand. So, the trick comes like this. What you have to do is, first of all, you write the name of 4 subshells like S, P, D, F. Then under that you just put numbers like 1, 2, 3 and 4. Now what you have to do is listen carefully. Here is how we apply the trick. So you have got S here. So write this S 2 times. So after writing S 2 times, then what is coming next after S? P comes next. So you have to take PS in this reverse direction. See, don't take SP, PS in the reverse direction, write it 2 times, PS, PS. Then after that what? D comes. So write DPS, see, in this direction, reverse direction, DPS, DPS 2 times, DPS, DPS twice. Now what comes after D? F. So F, D, P, F in the opposite reverse direction, F, D, P, S 4 times, F, D, P, S, F, D, P, S. Now that is all. Half our work is over. Now a very easy simple thing to do is, see, look here. S here it is 1. Look at the number down S, it is 1. So what you have to do is start from here. For S put 1. Then where is the next S? Comes here, put 2. Then for this put 3, 4, 5, then 6, then next S is coming here 7, 8. Okay, now look at underneath P, it starts with 2, so we will put here 2. Where is the next P? 3, then P here 4, then 5, then 6, then here nothing, 7. Okay, now after that D, what is the number given under D? It is 3. So where is D here? So first row we don't have D, D starts from here, put 3, then 4, then here 5, then 6. Okay, now D is over, and after that lastly comes F. F is 4, so start from here. So for F, where does it start? Here 4, 5. Okay, now this is all we have got to do. Just look at this chart. Now very easily we can write the electronic configuration of any element with any atomic number. See, look here, I will take example, atomic number 23, vanadium. So vanadium's atomic number is 23. So now look at here, we will write, see, 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay, now we will start filling up. So 1s, how many electron maximum? Here 2. Then 2s, 2. 3, p will have how many electrons maximum? 6 electrons. I already told you here, s, p, d, f, 2, 6, 10. So here again s is coming, 2 here. Then for p, 6. Now we'll count and see, 2 plus 2 is 4, 10, 12, 18. So we have got up to 23. Again 4s2. So now 20 already. So lastly we have got 3 more electrons which will go here. So now this is the electronic configuration. Very simple. See how easy you can write this. Now lastly I will show you the electronic configuration of one more element. Atomic number is 32, which is germanium. Again we will write like same thing. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Okay, let me start filling this up. 1s2, 2s2, 2p6, 3s2, then 3p6, 4s2, 3d will have maximum how many electrons? 10 electrons. So shall we count and see? 2 plus 2, 4, 10, then 10 plus 8, 18 plus 2, 20 plus 10, 30. So we have got 2 more electrons which goes here. So see, this is any element you can take with any atomic numbers. You see, just follow this order. That is all you have got to do. Very easily you can write the electronic configuration, and it's very easy to remember as well. Hope you all have understood this concept clearly and enjoyed it as equally as I did teaching all of you. So very soon I will be coming with another beautiful and excellent trick for you all. And thanks for watching my video, and please share with your friends and subscribe to my video.